Okay, section 8.2 is the next section. The first problem gives us this conic section. It's an ellipse, and it wants to know the center and the major and minor axis. So we're going to have to convert this to standard form. So I'm going to write this 9x squared minus 18x, and I'm going to put plus 4y plus 8y, and leave a little bit of a space here, equals 23. So I can factor out a 9 from the first one, and I end up with x squared minus 2x plus something. And I can factor out a 4 here, leaving y plus 2y plus something equals 23. So what I'm going to have to do to complete this square is I'm going to have to add something right here to make it a perfect square trinomial. So that's going to be negative 2 over 2, which is negative 1 squared. Here on this side, it's going to be 2 over 2, which is 1 squared. So I'm adding 1 to inside of these parentheses, but keep in mind that 9 is going to get distributed. So 9 times 1 is going to be 9. I have to add 9 to the right side, and I also have to add 4 to the right side because I'm adding 4 here after I distribute the 4 to that. So when I'm done with this, I get 9 times quantity x minus 1 squared plus 4 times quantity y plus 1 squared equals 23 plus 9 is 32 plus 4 is 36. Now the equation for ellipse have a 1 here, so I'm going to have to divide everything through by 36 in order to get it in standard form for an ellipse. And that gives me x minus 1 squared over 9 goes into 36 4 times, plus 4 goes into 36 9 times. And now we have standard form, so now our equation's in the form that we want it in. Now, I'm going to pull up the formulas in the formula sheet because we can compare and find out exactly what we're dealing with. Okay, so now with ellipses, these are, you can switch these terms. It doesn't matter which one you write first, so you have to be a little careful here. Turns out that with the biggest one is A. So we have A in this case is 3. It's the larger of the two numbers. B in this case is 2. So A is the length of the semi-major axis. So we have A underneath Y. So we're dealing with this column right here. Okay, so we can use all the information from that column, which helps us answer all these questions because they ask us, they want to know what the center is. So if I write the equation underneath this, and I'll write it the way that they have it written here. So I've switched up these two terms in the formula to match up with what I have. So you can see that H is 1 and K is negative 1. So there's my center. And then also you can see that A is 3 and B is 2. So that helps us answer the second question, which is the major axis has length 6 then, and the minor axis has length 4. Because what A is it's half of the major axis, and B is half of the minor axis. So what this thing looks like, if you draw a rough sketch of it then, the center's at 1, negative 1, which is right here. The major axis, since this thing right here, we're in this column, we can see that the focal axis is the equation x equals h. So x equals 1 is the focal axis, which means this thing opens up or down. And if we go up 3, 1, 2, 3 to here, and down 1, 2, 3 to here, that's the major axis. And then the minor axis, you go over 2 in both directions to get the semi-transverse axis, or the minor axis, the co-vertices they're called. So we have the vertices and the co-vertices. So the major axis has length 6 and the minor axis has length 4. Okay, and the next question gives us an ellipse. It wants to know the center and the length of the major diameter, or the major axis. Once again, we're going to have to complete the square on this. So we have 14x squared plus 2x, and then we have plus y squared equals 1. So to complete the square on this, first of all, I'm going to pull out a 14 because I needed my a to be 1. If I do that, then the question is, what does this become? So I need to be able to multiply 14 by something in order to get 2. So that's 1/7. So this is going to be 1/7 x plus space plus y squared equals 1. All right, now I can complete the square. So I'm going to add b over 2 squared, which is 1/7 over 2, which is 1 over 14th squared to both sides. Now, it's 1 over 14 squared, but it's going to get multiplied by 14. So all I have to add to the right side is 1 over 14. Because, you know, you have to distribute this to this last term in order to get 1 over 14. So this becomes x plus 1 over 14 squared plus y squared equals this. Now I'm going to make this 14 over 14 for a common denominator. Add them together to get 15 over 14. And I'm almost there, but I want to get a 1 here because standard form for an ellipse has a 1 there. So I'm going to divide by 15 over 14 from both sides. So that 14 is still there. Forgot to write that. And then I'm going to, instead of dividing by 15 over 14, I'm going to multiply by 14 over 15. So I'll try to simplify this a little bit if I can. And, or I guess better yet, let me back up here. I'll move this 14 to the bottom. Instead of multiply by 14, I'll divide by 1 over 14. So then I could make this 14 squared in the bottom. So I know these numbers worked out really ugly, but if you compare, once again, the bigger one is right here for me. That's the smaller one. So this is my A. Well, actually, the square root of this would give me my A, because I can compare to this formula right here, where A squared is what's underneath. So this is my A squared. And from there you can compare and see that it's y minus 0, so k is 0. And it's x minus h, so h must be negative 1 over 14. So there's my center. Weird numbers, very weird numbers. But then it wants as well the major diameter, the length of the major diameter, which is 2a. So we got to take the square root of 15 over 14 because that's what a is. Because a squared equals this, like I said. So take the square root of both sides and you get a. Then double that. So it's 2 times the square root of 15 over 14 for my length of my diameter, which goes right here. Okay, the next question says a bridge underpass is in the shape of an elliptical arc like this. And it says that it's half the ellipse, it's 40 feet wide. So this is going to be 40 feet here. And it says it's 15 feet high. So it says an 8-foot wide rectangular truck to drive safely underneath. So that's going to be a rectangle like this, where I know it's not drawn to scale at all, but it's an 8-foot wide truck. And the question is, how high can it be? So that's like a y coordinate right there, because this is going over 4 up question mark. We're looking for that y coordinate right there. So what we're going to do is find the equation of this ellipse and then plug in 4 to find that corresponding y coordinate. So the equation for the ellipse is, this is a horizontal ellipse, so I'm going to use this one off the formula sheet in the first column. And then I can go ahead and plug in the center. I'm going to have this centered at the origin. I'll just call, you can put the axes wherever you want, so I'll just put it right at the origin. So 0, 0. So I have x squared over, now a in this case is half of 40, which is 20 squared, plus b, which is 15. I have to square that for b squared, equals 1. So there's my equation right there. I'll write that as x squared over 400 plus y squared over 225. And then I'll go ahead and plug in 4 in for x. And I'll solve for y because that's got to be the height of the truck. If I do that and solve for y, I get about 14.7 rounded to the nearest tenth. Okay, the next problem wants us to write an equation for this ellipse. It looks like the center, hk, in this case is at 0, negative 1, 2, 3, 4, 5. So we can go ahead and plug those in for h and k. And then a is the length of half the major axis, which is 1, 2, 3, 4, 5. So a is 5. And b is half the minor axis, which looks like 1. So we just have to plug all those things in. So y minus k, if you compare the formula to on our formula sheet, it's k, which is negative 5. So this will become plus 5 right here. Or I can just do y minus negative 5, which is what they want us, how they want us to keep it. B in this case is 1, like I said, and that goes underneath y in this case. So that'd be 1 squared plus x minus c, which is going to be, I'm comparing to this formula on the formula sheet. Let me put it up for you right here, where a is underneath x, because this is the one that opens horizontal with a horizontal focal axis. So you can, I know they have these two terms switched in their equation, so keep that in mind. But D is going to be RA, which is going to be 5 squared. So to finish filling this out, x minus h, which is 0, all over d squared, which is going to be 5 squared, equals 1. So for me, my a is -5. My b is underneath here, which is 1. My c is up here, which is 0. And my d is right here, which is 5. Okay, the next one for me anyway is a vertical ellipse, so we know we're going to be dealing with this one here, the second column, where we have a focal axis that's vertical. And then the center, HK, looks like it's at 3, -5. So we can plug that in. K is -5, so that'd be minus -5 squared over, and now B is, in this case, underneath the other term. So this is going to be, if you compare this formula here, that's going to be a squared, which is half the length of the major axis, which is 1, 2, 3, 4, 5. So it'd be 5 squared, which is 25. I'll leave it as 5 squared. Plus x minus, in this case it's h, so 3 squared over, and this is going to be b, which is half the length of the minor axis, which is 1. So now I can just compare. They want a to be -5. My b is 5, c is 3, and d is 1. Next problem is really easy because it just wants you to move this thing to the origin, so all you have to do is make these zeros. So it's going to be x squared over 8. Actually, I'm sorry, this is x squared, but also I need it, if I'm going to do this the same way, I have to keep this in parentheses. So it'd be x over 8 squared plus y over 3 squared. Okay, next one wants an equation of an ellipse with these properties. So I'm going to graph this really quickly. So here's my ellipse, and then my a is obviously this length here, which is 25. So I have x squared over 25 squared plus y squared over my b is 16. 16 squared equals 1. So on the formula sheet, I'm using the first one because that's the horizontal ellipse, and it's centered at the origin, so h and k are 0 and 0. So there's my equation right there. Okay, the last problem then wants to find an equation with foci here, major axis length 26, and it wants to express our answer like this. So let me first graph this thing. So from this, I know that a is 13 because that's half the length of the major axis. And I can also get the center by taking the average of these 2 points. The x-coordinate would be the same, but the y-coordinate would be 5 plus -7, which is -2 divided by 2, which is -1. Average of the y-coordinates, or the middle of these 2 y-coordinates. So now I know the center, HK, as well, which is -6, -1. I'm going to start filling this out. It's a vertical ellipse, so I'm going to write down that equation right off the formula sheet. Now I'm going to plug in h and k and a. Now they want me to rearrange this because they want it to be equal to 0, so I'm going to have to get a 0 over here. I'm probably going to have to FOIL this all out somehow. They also want a coefficient on x squared of 169. So that means I can multiply through by 169 here to every term. And the reason why is because this is 169, 13 squared, so that'll cancel. And I'll be left with this. And now I can subtract 169 from both sides, and I end up with this. Now to find b squared, I'm going to use this right here, this Pythagorean relation at the bottom. It's a squared, which we know a is 13, so 13 squared would be 169 equals b squared plus c squared. Now so what c is the distance from the middle to the focus, which is 6 units. So, and if you're not sure, you can use this right here in the formula sheet. It gives you what the foci should be, and it gives you the actual coordinates of the foci, and we have h and k, so you can find c, and what you'll get is 6 for that. So this should be 36. So if we subtract and take the square root, we should get b equals the square root of 133. So if I put that here, square root goes away, and it becomes just 133. So this should give me the right answer, but for some reason, when I enter it in, it's not working, and I don't see anything wrong with it. I've double checked it and everything, so that should be right though. Solving it for 0, obviously, and putting everything on the left side. I'm not sure if it wants you to FOIL these out or what, but this should work, and for some reason it's not. So I'm going to have to give us credit for this problem for now.